Oi, you sleeping ah? What time already? We are supposed to meet at 1, right?
Ayah, relax lah. 20 minutes only what. Chill.
Now 12:40 already ah. You better reach there by 1 hor.
I'm on my way. Oh, I'm late. Ayah, okay lah. 20 minutes for me to travel there. But I need 10 minutes to prepare leh. Oh, late liao lor.
Oh there's a red light. So what should my solution be so that I can be there on my intended time?
So, what is differentiation? Differentiation is the slope of a curve at point P, which is defined as the slope of the tangent at point P. We need to find this slope to solve many applications to physical problems. It also tells us the rate of change at a particular point. By definition, m is equal to the change in y over change in x. Differentiation can help us in solving many real-life problems. For example, finding profit, loss, cost of shipbuilding, strength of ship, and many more. They help us by determining the maximum and minimum values of a particular function. They can be expanded all the way up to Newton's law. Derivatives can be used to estimate functions. In other words, they can be used to describe how a function is changing. The function can be increasing or decreasing. If so, how to find out how much is increasing or decreasing? Derivative will help us to find it out. They can be used in L'Hopital rule to evaluate limits.
Using a kinematic speed equation for the previous scenario, we can derive velocity is equal to initial speed, which is represented by u, plus acceleration multiplied by time. So substituting all the values, we get acceleration is equal to 0.19 meter per second squared.
Therefore, in comparison to the rate of change, when variables are changing over time, there is a relationship between the two variables. Acceleration is equal to dv over dt, which is also equal to the change in velocity over change in time, which will give us 0.19 meter per second squared.
So, John has to accelerate that much in order to be there on his intended time. Applications of differentiation. Let's take a sheet of metal which has an area of 64 centimeters squared. So how do we find the maximum possible volume for the box with a square base with no top? Hence, 64 centimeters squared is equals to x squared plus 4xh. Next, we take the volume, which is V, equals to x squared times h. By substituting 1 into 2, we can get volume, which equals to 16x minus x cubed divided by 4. We have to find the first and second derivative. The first derivative is to get the absolute extrema to find the maximum value of the function we want to optimize. The second derivative is to help us identify the optimal value of a function. When dv over dx is equals to 0, the x value is 4.6188 cm. Hence, h is 2.309 centimeters. Therefore, the maximum possible volume for the box is 49.267 cm3. For example, we can use this method to find out how much water we can fill in a pool. In conclusion, optimization is the action of making the best of a situation or resource. We know that we can find the maximums and minimums using derivatives. Therefore, one can conclude that calculus will be a useful tool for maximizing or minimizing a situation.